you know what is the distance between the Earth and a far, far away star? Or do you know anything about the dimensions of proton or electron? So, are these numbers easy to read? Join me to talk about it. Hi, welcome back to Physitopia. This is Fatima Sadat, and today I'm going to talk about scientific notation. As I told you, big numbers or small numbers are hard to read, so it's better to show them by a special kind of numbers that we call them scientific notation. If you like this video or the past videos, please subscribe my channel and like or comment the videos. So let's go to the board and talk about it. Okay, welcome back to my board. So, if you want to show a very big or very small number, you are supposed to, or actually it's better to use scientific notation. So instead of writing 1 with 6 zeros, I just simply say it is 10 to the power of 6. Or instead of show this a small number like that, I say it's 10 power minus 5. So now we are going to learn how we can write numbers in scientific notation, or how we can change scientific notation to a standard form. Let's start by changing scientific notation to the standard form. Imagine that you have this number. 10 to the first is simply equal to 10. So it is equal to 10. And you can say 4.5 times 10 is equal to 45. Look at here. Now I have this number. 2.3 times 10 power 2. 10 power 2 is actually 100. So I say 2.3 times 100, and it will be equal to 230. Now, it's your time. Tell me the answer of this. Ten power 3. Feel free to pause the video and answer this question. Okay, 7.4 times 10 power 3 is actually 7.4 times 1,000. And 7.4 times 1,000 is actually 7,400. So, you can say, if you just compare the answer here and also this multiplication here, you can see that actually I have moved the point by 3 digits to the right. So look, if it is 7.4 and I am moving the point to the by 3 digits to the right, so I can say 1, 2, 3, and now point is here, and I have to put zeros here. So actually it is 7,400, and it's the same as you can see here. Guys, if you want to test it yourself, you can do this exercise. Try it. Use both methods. moving point, and also multiplication. So, if I want to just use this multiplication form, I can say it is 4.28 times 10,000. So it will be equal to 0, 0, or 42,800. If I want to solve it with moving point, I can say it's 4.28, and I'm going to move point by 4 digits to right. So what am I supposed to do now? 1 digit, 2 digits, 3 digits, and 4 digits. Now the point is here, and I have to put zeros here. So this number will be 0, 0. You can see both numbers are the same. You can do these exercises for yourself at home and comment your answers for me. So let's try these examples together. 8.69 times 10 power 4. 9.1 times 10 power 3. 4.76 times 10 power 2. So when you have positive power, so we are talking about a big number. So positive power means a big number. So you have to move decimal towards right to make your number bigger. Point towards right. So let's go. Feel free to pause the video and answer these examples by yourself, and then check your answers with me. But right now, I say, okay, I have 8, 6, 9. First decimal is here, power is positive, and I'm going to move point by 4 digits toward right. So 1, 2, 3, and 4. So point is here, 0, 0. So actually, your number is like that. 8, 6, 9, 0, 0. You are making your number bigger. Let's try for it. I have 91. First point is here. I'm going to move it by 3. So 1, 2, and 3. Now point is here, 0, 0. So it will be, number is 9100. The next example, I have 476 here. I have to move decimal by 2 towards right. 1, 2. So number will be 476. So as you can see, I'm making all the numbers bigger than before. Compare the numbers. Positive power shows that your final answer should be bigger than the original number. But always, power is not positive. Let's check it. Here, in this example, 10 power minus 2. So 10 power minus 2 is talking about a small number. 10 power minus 2 itself is 0.01. So when you are multiplying by this number by 0.01, you are making your number smaller. So let me just write here. Negative power we are talking about a small number. You're making your number smaller. And so you are moving your point toward left. So move point towards left. So look at this example. I write 34 here. I say point normally is here, okay? Point is here. But I have to move it by 2 towards left. So 1 and 2. Point will be here. And I have to put a 0 here too. So my answer will be 0.034. Let's check another example. 4.5 times 10 power minus 3. I write 45 here. I have negative power. Negative power means that you're making your number smaller, so you have to move your point towards left by 3. So your point is here, 1, 2, and 3. Your point is here now, and I put in every, instead of every digit, I put 1, 0. So your number is 0.0045. Let's have a few examples. You can do them by yourself. Pause the video, do them by yourself, and then check your answers with me. I can say 8.8 times 10 power minus 1. 3.62 times 10 power minus 5. So if you want to pause the video, feel free and solve it by yourself and then check with me. So first I check that the power is negative, so I'm making this my number smaller than before, and I have to move point towards left. So I write 88 here by 1. First point is here, so I put it here. My number will be 0.88. Or for this one, I write 362. Then I say point is here. I have to move it by 5 to our left. 1, 2, 3, 4, and 5. So point will be here. I put zeros, 4 zeros, and so I can say my number is 0.000362. So this is my number. So now let's talk about a standard form to scientific notation. Now let's go backwards. I mean that I'm going to change a standard form number, a normal number, to scientific notation. Look at here. I have this number. Okay? So normally decimal is here after the last digit. But for scientific notation, the point should be between two first digits. Here is 4 and 6. So, for decimal number, always the point is between two first digits. I have to move it 1, 2, 3 by 3 digits and put it here. So, 8D. Okay, so recall large numbers are associated with positive exponents. So, I put the positive exponent for 10. How much? 1, 2, 3. I have moved my point by 3 digits, so I put 3 here. Let's do another example. Also, you can just double check it if you want. I mean, change it to a standard form and check your answer by this answer. If you have done it correctly, two answers should be the same. So let's have another example. 32,500. So again, decimal is here. I have to put decimal between two first digits. So 1, 2, 3, and 4. Decimal should be between 3 and 2 to have a scientific notation. So 3.2500. Also, because they are the last digits after decimal, you can just drop them and just write 3.25. It's enough, okay? So, times 10 power. Because it's a large number, so the power should be positive. And I have moved my decimal 1, 2, 3, and 4 by 4 digits. So here I put positive 4. Another example, I have 476. So I'm gonna change it to scientific notation. I move decimal is here. I move it by 2 because it has to be between two first digits, between 4 and 7 here. So now I tell it is 4.76 times 10 power, because it's a positive, it's a big number. I put positive exponent for 10. So I write 2. I have moved the decimal by 2 digits. So try these examples and change them from a standard form to scientific notation. 37,950, 450,000, 38 million. Okay. So I can say I have put decimal because decimal is here. I have put decimal between two first digits, 3 and 7. 1, 2, 3, and 4. It's a big number. I write 3.7 times 10 power positive 4 because it's a big number. Here, decimal should be between 4 and 5. 1, 2, 3, 4, 5. 4.5 times 10 power positive 5. It's here 1, 2, 3, 4, 5, 6, and 7. 3.8 times 10 power 7. Guys, try to pause the video, and before I answer these examples, answer by yourself and just check your answers with me. But let's try to change very small numbers to scientific notation. Here I have 0, 0, 2, 4. And because I want to make a scientific notation, I have to put decimal point between the first two non-zero numbers. I mean here. So I have to move decimal by 1, 2 to put decimal here. So now it is 2.4 times 10 power. Because it's a really small number, power should be negative. How much? 1, 2 digits. So here will be negative 2. So let's make another number. Let's have another example. 0.0036. So I have to move decimal and put it between 3 and 6. 1, 2, 3. So it will be 3.6 times 10 to the power minus 1, 2, 3. Minus 3. So another example I can give you is, where is it, my black marker? 0.00071. I have to put decimal between to the two first non-zero numbers, 7 and 1 here. 1, 2, 3, 4. So now 7.1 times 10 to the power minus 4. But let's try another example. What would happen if we have a number like that? I have, for example, 3 non-zero digits. So, guys, I told you are supposed to put the decimal between the first two non-zero numbers, okay? So, I have put decimal between 8 and 2 because they are the first two non-decimal numbers. 1, 2, and 3. So, it will be 8.25 10 power minus 1, 2, 3. So don't forget that if your number is big, power should be positive. If the number is small, power should be negative. So let's talk about something that is very important in scientific notation. Let me just highlight this important point by giving an example. 4, 2, 5, 4. Right now, both numbers are multiplied by 10 power 0. Actually, 10 to the 0 is 1. So, anything raised to the 0 power is 1, as you know. Everything that has power 1 is equal to 0. So, if I want to make this number like a scientific notation, look at here. I have put decimal between 8 and 6, 1, 2. So it will be 8.6 times 10 power minus 2 because it's a small number and I have to write a negative number for it. But look at here. If I want to make it scientific notation, I have to put decimal 1, 2, 3 between 4 and 2. So it will be 10 power 3. Okay, let's compare these two numbers. Look at here, decimal is moving from here to here. So it is moving toward right. Here, decimal is moving from here to here. So it is moving toward left. Now let's compare exponents. Here is 0 becomes negative 2. So it is decreases. But look at here, it is 0 and now it is 3. So it is increased. You can say that whenever you are moving decimal, okay, you are moving decimal to right, you are decreasing exponent of 10. And when you are moving it toward left, you are increasing exponent of 10. Look at this example. 42.8 times 10 power 5. So, as you know, if I want to make a scientific notation from this number, I have to move decimal toward left. So, it will be 4.28. Okay? I move this toward left by 1 digit. And I have to increase the power of 10 by positive 1. Okay? By positive 1. So, instead of 42.8, I wrote 4.28. And because I moved decimal by 1 digit, I put power 1 for 10, and because it is moving toward left, I am increasing power of 10. So it will be positive 1. And I write 10 power 5 here. So you know that it will be 4.28 times 10 power 6. 5 plus 1 is 6. If you cannot remember the rule about the powers, I have to say, I think that you had it before, that if you have, for example, a number that has power of 2 times a number that has power of 7, for example, answer will be the addition of two exponents, or z power 9, for example. So let's try these examples. $37.4 times 10 power 5, 426.8 times 10 power 7, 0.0046 times 10 power minus 3, 0.081 times 10 power minus 4, and 76.1 times 10 power minus 5. So, remember this rule that if you are moving decimal to left, power of 10 increases. If you are moving decimal to right, power of 10 decreases. So, let's check it. I have to move this point between 3 and 7. So, I have to move it by 1. I have to move the point by 1. So, because I am moving to left, I have to increase the power of 10. So, I have to change it 5 because I have moved my point by 1 unit. I have to change it to power of 6. Here, I have to put decimal between 4 and 2. 2 digits. Because it's moving toward left, I have to increase power of 10. So, it will be 10 power of 9. 7 plus 2. Here, I have to move decimal between 4 and 6. 1, 2, 3. Because it is moving toward right, I have to decrease the power of 10. So, it will be 4.6 times 10 power 1, 2, 3 digits. It has moved by 3 units, so it will be 10 power minus 6. Here, I have to put decimal between 8 and 1, so 1, 2. It will be 8.1 times 10 power 1 2 digits toward right, so I have to decrease power of 10. It will be minus 6, and here I have to change decimal, put it between 7 and 6. It's moving toward left. I have to increase power by 1. Increase power by 1. So it will be 7.61 times 10 power minus 4. So I think that it's enough for this session, and we talk about algebra of scientific notation in the next video. If you like this video, please don't forget to like it, hit the subscribe button, and I'm looking forward to checking your answers on the comment part. Have a nice time. Bye bye.